Well, welcome to part 3 of Bumble Bee Foraging. Here we're going to look at energy consumption and needs and foraging distances based on a little bit of a literature review on this subject. So first of all, let's look at some wind tunnel studies that were done to determine how fast bumblebees can fly. And from these wind tunnel studies, it was found that about 4.5 meters per second, which is about 10 miles per hour, is a speed that was common in these studies. Also, photographically, researchers have recorded that the frequency of wing beats is about 160 to 200 beats per second, and that a larger bee will have a slightly lower frequency than smaller bees. But also interestingly, that this frequency was maintained no matter how fast the bee was flying, whether it's hovering or traveling forward. So very interesting results from those studies. From other studies, we see Riley and colleagues reporting flight speeds of over 7 meters per second. And in radar studies by Osborne and colleagues in '99, they reported speeds of 3 to over 15 meters per second, which reaches 30 miles per hour. But they do mention that there was variable winds here, and it's possible that that upper number could be wind assist. But in terms of energy costs, and you can ignore a lot of this detail, but in terms of energy costs, and I apologize, the photograph is not Bombus terrestris, but at any rate, the researchers that Goulson reports on have a pretty good idea of what the oxygen consumption is in terms of bees. They report that commonly flowers will have nectar sugar contents between 40 and 60%, and that they know that sugar can yield almost 17 kilojoules per gram, and the stomach capacity of bees is about 80 microliters. So when they do the calculations, they come up with a potential foraging distance of about 10 kilometers. So that is possible based on calculations. But what do we know about field studies? Now, before I go over that, let me just say that one of the things that Goulson points out, that bumblebees, when you compare these studies to other organisms, they have the highest recorded metabolic cost of any organism, or at least one of the highest, and that this is 75% higher than a hummingbird, which says a lot. In terms of rearing, what's it cost a bumblebee colony to rear a worker bee? Well, check out Dr. Strange's YouTube lecture on bumblebee biology, because in there he gives graphics to show that on average they have found, now I believe they were studying Bombus huntii, but they found an average of about 470 milligrams of pollen per bee reared. And to get that, based on, Strange says, some of Goulson's comments, that a bee could carry about 26 milligrams of pollen per trip, which would mean that you would need to have 18 trips for each bumblebee reared. And if you recall from our other lecture, that the average trip from Strange's study on foraging, amounts of time that they spend foraging, that the average trip for pollen was an average, of 30 minutes. So anyway, that gives you some idea of what it would cost to raise a bumblebee worker, 470 milligrams. Now, what about foraging distance? How far will they go to get these resources? Well, in a study by researchers in Colorado looking at 4 alpine bumblebee species, they were looking at how these bumblebees would fertilize, the success of fertilization of several alpine plants. They were shocked to find out that the ranges were really small, only 25 to 110 meters, which isn't very far. So on foraging studies on Bombus terrestris, the buff-tailed bumblebee, Osborne and her colleagues report a mean foraging distance of 275 meters. The range ran between 70 to 631 meters, which means at the high end they were over 2,000 feet out. They also note that they foraged well beyond the near resources. In other words, a lot of authors talk about this and say not as many bumblebees, although there's some, the majority are going to be foraging away from the colony or the nest. That could be, and authors point out that in theory that could be so that they aren't attracting predators or parasites to their nest. However, these authors point out that we don't know what the floral quality was, so it could have been that as a reason as well. Another finding is that on successive trips, individual workers would maintain a constant bearing and destination on each of those successive trips. So that's a pretty remarkable finding. So Goulson points out that in this study, you can actually look at differences in time. So the mean maximum for June was 339 meters, but in August it dropped down to 201 meters. Now there was an issue with the radar, that the authors point out that in the June study a third went beyond the radar's capability, and in August half went beyond the radar's capability. But you know, a decade later they've improved their capabilities, and you're going to see in the next slide that report. In a later study, Osborne and colleagues found that the distance for foraging was up to 1.5 kilometers. That's close to a mile. But the linear, the further you went along that foraging distance, there was fewer and fewer bees. And they point out there was a lot of variation in the floral resources that were close within 500 meters, but they were more uniform beyond the 1 kilometer. So this might indicate that the bees are looking for good sources of nectar and pollen, and it's worth going that distance, and they're capable of doing that. So here are the takeaways. So we see bumblebees have a high energy need. They're burning a lot of energy because they're generating warmth and they need that nectar for flight. And they can travel out hundreds of meters, and it's been documented up to 1.5 kilometers. So almost close to a mile. They tend to go beyond the nest, so you'll see fewer individuals close to the nest, and they will return to reliable resources. If they find a reliable resource, they're going to go back over and over and over again. Remember, time of day matters too. So nectar, they're going to be seeking in the morning hours, and hopefully it'll refresh by the following day. This will vary by the available resources, and with the landscape, that's going to have a huge impact on where they go and what they're feeding on. And it will also vary by the species. A lot of what I told you is from the buff-tailed bumblebee, Bombus terrestris, which is European. It's one of the most highly studied bumblebees, the European bumblebee. But we're seeing more and more data from Huntii and some of the Native American bumblebees. So with that, I refer you to the articles. These articles can all be downloaded and read directly from an internet search. Go by the titles, scroll back if you need to. And the two main sources that I used were the Bumblebee textbook by Oxford University Press by David Goulson, and the Bumblebee biology talk on YouTube by Ohio State University professor Dr. Jamie Strange. I recommend those for the details. Well, thank you very much for taking the time to learn about bumblebees. I found this topic really fascinating, and the capabilities and the activities of bumblebees, I just find them fascinating. So thanks for your interest. Next talk in 2 weeks is going to be about No-Mow May, and I hope you'll join me for that. So take care, and thank you.